work.
In order to use a computer effectively, it's useful to know how a program works. That's what we'll talk about here. You may recall that previously we looked at entering in direct commands into the computer. For example, I could say print 33 plus 44, and the computer would reply 77. That's called a direct command. We could put exactly the same type of command into a program, in which case we would call it a statement, and it would be stored and used later, not used right away. So here's what we might do. In order to store a command, we put a number in front of it. I might put a number here, 100, and then behind it the same command, print 33 plus 44. And when I press return, the computer, instead of performing the command, will store it away, and then we can use it at a later time. Command, we didn't print the answer now, the instruction is stored. Now, if you want to enter a program, you have to be careful, first of all, that any old programs you have in there are disposed of. You don't want them sitting around. You want to start with an absolutely fresh computer, so you say wipe out the old programs by typing in the word new, N-E-W. Now we're ready to type in the instructions of our own program. We're using a simple language which is called BASIC. BASIC has simple commands such as print, input. We've seen some of them before. You'll find many of them in the Commodore 65 User's Guide. Now, let's take a look at why we would store commands. Why don't we just type the command in and get the work done right away? Well, it turns out that when you gather commands together into the computer's memory as a program, some brand new things start happening that you don't get with direct commands. These basic statements can work together in a brand new way. There are, of course, always the commands that do things, the commands that print, the commands that calculate, and so on. But there are some new kinds of commands. For example, there's one set of commands that's good for creating repetition, so we can do something over and over again. Here's the idea. Once we've stored a command into the computer's memory, we can do it as many times as we want. Hundreds of times, we don't have to put it in again. If we can only bring in repetition, what some people call looping, because the program goes back and repeats again, then we can use that program statement over and over again and save a lot of work. Second thing that we have here is the ability to use some instructions and not use others. Let me give you an example. Suppose that we're printing out a large number of customer bills, and we have written into our program to say, print on the bill, your bill is now overdue, please pay promptly. Now, we don't want to use that communication every time. There are some communications, there are some customers who will have their bills up to date, and you don't want to print that message. So here's what we need in the computer. We need decision. We can decide, yes, we'll perform this activity, or no, we'll skip over it and go on to the next part. So here are the three parts. First of all, the action part, the part that does things. Second of all, the repetition part, the part that goes back and does the same thing for the next customer or the next item of information. And thirdly, the decision part, saying, in some cases, perform this piece of these set of instructions. In other cases, don't. Skip them. Now, with all of those, we can have the flexibility we need in our computer. Now, there's one more thing that's useful to know when we're talking about how a computer handles information, and that is variables. Suppose we have some calculation we want to do, but when we write the program, we won't know what the numbers are. We won't know what the sales results are until they come in, and we're writing the program beforehand. We won't know the customer's name because the customer might not walk in until a month after we finish writing the program. So what we have to do in the program is we have to leave blanks in the program and say, we'll fill these blanks in later. And we can tell the program to work on these blanks and make all of this stuff work at the time. Now, these blanks are called variables. In BASIC, anything that we give a name to is a variable. For example, I can say x equals 123, and when I press return to say, do that calculation, the variable called x will be stored somewhere in the computer's memory, and it will hold a value of 123. But any time later, we can say to the computer, print x, and the computer will look in its memory find the variable or the blank we have filled in called x and print its value 123. In fact, we can do more than that. We could say print x plus 100, and when the computer goes into its memory, it will print 223. It fetched the value of x and then performed the rest of the arithmetic. These variables, these things to be filled in later, are very important. If we didn't have them, the computer would always have to calculate on the same numbers every time. But there's more than numbers. There are also names. We can store names and addresses and codes and anything we want to in a non-numeric fashion. We call this kind of thing a string variable. Let me show you one. If I say x with a $sign behind it, what I mean is this is not a conventional variable for use in arithmetic. It's not a number. Instead, we have a name. Okay, let's take a look. We say x string equals, well, we can put in a name, Jim Butterfield, and once again, when I press return, the computer will say, okay, I'm now holding a filled-in blank area called x string, and filled into that space is a name, Jim Butterfield. Now, these things work together. With the blanks that we can fill in, called variables, and with the control features that we have, the repetition and the decision, we can write a program to do almost anything. In a moment, we'll talk about how we can fill programs into the computer.